Kotlin Flow, reactive streams, StateFlow, SharedFlow, and operators. Imagine you are building a search feature. The user types a query, and results should update as they type. Or you have a dashboard that shows livestock prices, weather updates, and notifications. These all involve streams of data that change over time. Flow is Kotlin's answer to reactive streams. It lets you emit multiple values over time with full coroutine support. In this video, we will learn everything about Flow. Flow is a cold asynchronous stream that emits values one at a time. Cold means it only runs when someone collects it. No collector, no execution. Compare this with channels which are hot and run immediately. A regular function returns one value. A suspend function returns one value asynchronously. A flow returns multiple values asynchronously over time. Think of flow as a function that can return many values, pausing between each one. There are 3 ways to create a flow. The flow builder lets you emit values one by one with custom logic. Use flowOf to create a flow from a fixed set of values, like flow of hello, world, Kotlin. Use asFlow to convert any collection or range to a flow. The flow builder is the most flexible. Inside it, you call emit to send each value. You can add delays between emissions to simulate real-world data arriving over time. The collect function is the primary way to receive values from a flow. It is a suspend function that runs the flow and processes each emitted value. Because flows are cold, each call to collect starts a brand new execution. If you collect the same flow twice, the code inside the flow builder runs twice. This is different from channels where values are consumed once. Every collector of a flow gets its own independent execution. Flow operators transform the stream. They are similar to collection operators like map and filter, but they work lazily. The map operator transforms each element. The filter operator keeps only elements that match a condition. The take operator limits the number of elements. And transform is the most flexible, letting you emit 0, 1, or many values for each input. You can chain multiple operators together to build processing pipelines. Terminal operators start the flow execution and produce a final result. The toList function collects all values into a list. The first function gets the first element and cancels the rest. The reduce function accumulates values without an initial value. The fold function accumulates with an initial value. And count returns the number of elements. These operators suspend until the flow completes. They are called terminal because they trigger the actual execution. The flowOn operator changes which dispatcher runs the upstream flow. This is important for performance. You want heavy computation on the default dispatcher and network calls on I/O. But the collector still runs on the original dispatcher. Never use with context inside a flow builder. It violates the flow contract and throws an exception. Always use flowOn instead. Place flowOn after the operations you want to move to a different dispatcher. The combine operator merges 2 or more flows. Every time any flow emits a new value, combine produces a new result using the latest values from all flows. This is perfect for UI state. When the search query changes, the combined output updates. When the sort order changes, it updates again. The zip operator is different. It pairs elements one to one. It stops when either flow completes. Use combine for UI state and zip for pairing related data. Error handling in flows uses the catch operator. Catch handles exceptions from upstream operators. It does not catch exceptions in the collector. When an error occurs, catch can emit a fallback value or log the error. The retry operator reruns the flow when an exception occurs. You specify the maximum number of retries and a predicate that decides whether to retry. The onCompletion operator runs when the flow finishes, whether successfully or with an error. The conflate operator skips intermediate values when the collector is slow. The collector always gets the most recent value. This is useful for sensor data or live prices where you only care about the current reading. The distinct until changed operator filters out consecutive duplicate values. If the same value is emitted twice in a row, the second emission is skipped. This reduces unnecessary UI updates when the state has not actually changed. The flatMap family of operators handles nested flows. flatMap concat processes inner flows one at a time in order. Each inner flow must complete before the next one starts. flatMap merge processes inner flows concurrently for better performance. flatMap latest cancels the previous inner flow when a new value arrives. Use flatMap latest for search as you type. When the user types a new character, cancel the old search and start a new one. Here is a practical search with Debounce Pattern. The Debounce operator waits 300 milliseconds after the last keystroke before processing. Distinct until changed ignores duplicate queries, and filter skips blank queries. The map operator performs the actual search. Without Debounce, every keystroke triggers a search. With Debounce, the search only runs after the user pauses typing. This reduces server load and improves user experience dramatically. StateFlow is a hot flow that always holds a current value. It emits the current value to new collectors immediately and only emits when the value changes. Setting the same value again does not trigger a new emission. This behavior is like distinct until changed built in. StateFlow requires an initial value. You create it with mutable StateFlow and expose the read-only StateFlow interface. This pattern is the standard way to manage UI state in modern Kotlin apps. SharedFlow is a hot flow that can emit values to multiple collectors. Unlike StateFlow, it does not require an initial value and can emit the same value multiple times. Both collectors receive every event. SharedFlow is perfect for one-time events like navigation commands, snackbar messages, or error notifications. You can configure replay count and buffer capacity. Replay lets new collectors receive past events. Buffer handles slow collectors. StateFlow is for state that changes over time, like user data or loading status. SharedFlow is for events that happen once, like clicks or navigation. StateFlow requires an initial value and skips duplicates. SharedFlow does not require an initial value and emits every value, even duplicates. Use StateFlow when the current value matters. Use SharedFlow when every emission matters. In Android, view models typically use StateFlow for UI state and SharedFlow for events. The stateIn and shareIn operators convert cold flows to hot flows. stateIn converts a cold flow to a StateFlow with an initial value. shareIn converts a cold flow to a SharedFlow with configurable replay. Sharing started controls when the upstream flow runs. Eagerly starts immediately. Lazily starts on the first collector. While subscribed starts on the first collector and stops when the last unsubscribes. While subscribed with a timeout is ideal for surviving Android configuration changes. There are 3 common mistakes with Flow. First, using with context inside a Flow builder. This throws an exception. Always use flowOn instead. Second, collecting on the wrong thread. Heavy work in the collector blocks the main thread. Move heavy work upstream with flowOn. Third, not handling errors. An uncaught exception in a flow crashes your app. Always use the catch operator to handle errors gracefully and emit fallback values when needed. Let's review everything. Flow is a cold stream that runs on collect. Use the Flow builder, flowOf, or asFlow to create flows. Operators like map, filter, and take transform the stream. flowOn changes the dispatcher. Combine merges multiple flows. Catch handles errors. StateFlow holds a current value for state management. SharedFlow broadcasts events to multiple collectors. stateIn and shareIn convert cold flows to hot flows. Flow is the foundation of reactive programming in Kotlin. If you liked this video, hit the like button and subscribe for more tutorials.